Assalamu alaikum students. Today is our next online lecture, and today we will study LU factorization or LU decomposition. LU factorization or LU. The basic concept of this LU factorization or LU decomposition is you have to convert this if you have the system like AX equals to B. A is the coefficient matrix, X is the matrix of unknowns or column vector, and B is the constant column vector. So you have to decompose it or factorize it a coefficient matrix into L cross U. So be sure about the order. That first matrix is the lower, L means lower triangular matrix, and the second matrix is the upper triangular matrix. So as you know that the matrix multiplication is not symmetric. LU is not equals to U into L. So you have to write it L first. So lower triangular means all the entries that in the lower triangular is non-zero, and the upper triangular entries are 0. So L11, L22 and L33, and all the upper entries are 0, and these are non-zero, L21, L31 and L32. So this is the lower triangular matrix into U is the upper triangular matrix. So U11, U22 and U33. So lower entries are here 0. So U12, U13 and U23. So now your matrix is decomposed. Now to solve this matrix system, you have to make it, now you're converted, it is basically decomposed into L into U. So LU X equals to B. Now that is your step number 1. That is step number 2. So let UX, consider UX equals to Y. Okay, step number 3. Y is some constant vector of unknowns Y1. If you have 3 cross 3 system, then you can say it as Y1, Y2, Y3. So now you replace this Ly equals to B. So basically L is the vector of unknowns, because you multiply these entry by entry, you compare it by multiplication, and it gives the entries of lower triangular matrix. So you solve it by Y equals to B divided by L, or it can be solved easily and Y can be determined. So step number 4 is the last step, and you replace this Y back into UX equals to Y, and then X equals to Y divided by U. So that eventually solves or compare the system coefficient matrix unknowns and the Y vector, that solves the solution set. If you have X, Y, Z, then it can be the values of X, Y, Z, or X1, X2, X3. If we have to deal with X 3 cross 3 system, X3 can be determined, and we will get the same solution as we have done the methods before, that is Gauss elimination method and Gauss-Jordan elimination method, and we get the same solution with the LU decomposition. If the solution is consistent and the system is consistent, and the solution is unique, then you get the same solution by this. Now there are 2 ways to solve this LU factorization. Okay, in the Crowd's method, what you need to do, you just have to replace U diagonal entry as 1. Okay, so I replace these diagonal entries as 1, and then solve the equations entry wise. You use the same 4 steps to solve the equation. You will get the same solution as before, like Gauss elimination and Gauss-Jordan elimination. Okay, and in Doolittle method, if I replace it back, U11, U22 and U33. In Doolittle method, what you need to do, you replace this L lower triangular diagonal entries as 1. So simple, that is so simple. So replace L11, L22, L33 as 1, 1, 1 and solve the system and use the 4 steps before. So there is an additional method that is known as the Cholesky's method. Okay, for Cholesky's method, there is some condition that your matrix should be symmetric. You have to check. Your matrix should be symmetric and positive definite. If there are two conditions, then you can replace A, you can decompose A as completely in the form of upper triangular matrix or completely in the form of lower triangular matrix based on the, but don't forget its order. If you want to replace totally in the lower triangular form, then L multiplied by, in place of U, you replace it L transpose. And if you want to replace completely in terms of upper triangular matrix, then don't forget the order. Replace L as U transpose into U. Then you can solve the system. So Doolittle and Crowd's method has the same solution as the before methods we have done.